Good morning, viewers. Welcome to Telepedia Tutorials. We have been on this electrolytic series. We have looked into key differences between molten and aqueous electrolysis, and we have looked into molten electrolysis fully. I think the three remaining you can do it by yourself. This hematite and galena, the primary way of extracting their metals from these ores is what we call chemical reduction process using carbon. You can go and look it up. But based on the understanding of the processes of molten electrolysis, one will still follow the methods we use in bauxite, magnesium chloride. We are still going to extract iron from hematite and lead from galena. But the primary way of extracting these metals is by chemical reduction process. Now, so furthermore, we're going to look into aqueous electrolysis. Once we're talking about aqueous electrolysis, preferential discharge of ions comes in because, as I told you, in aqueous electrolysis, both the electrolyte is going to ionize and water also will ionize. Hence, we're going to have two cations and two anions. There is going to be what we call preferential discharge of ions, that is, which of the cations will be discharged at the cathode and which of the anions will be discharged at the anode. I will say that there are three factors that influence this: position of the ions electrochemical series, concentration of the ions, and nature of the electrode. So we're going to look into aqueous electrolysis fully. So this is aqueous electrolysis now. There's electrolysis in the presence of water, and we're going to concentrate on the two factors we mentioned. So the first factor is position of ions in the electrochemical series. So we are saying that when two competing cations. First, electrochemical series is a series that gives list of ions with respect to their reactivity. So ions that are above are more reactive than ions that are below. The same applies to the anions. So this is cations, this is what? Anions. These ones are highly reactive. As you can see, they can only be gotten through molten electrolysis. These ones are moderately reactive, and while these ones are least reactive. The same thing applies here. The three that are most above are highly reactive, and they are not usually gotten from aqueous electrolysis. They can be gotten from molten electrolysis, especially fluorine. While the ones below, they can be gotten through aqueous electrolysis. As I said, with respect to position of ions in the electrochemical series, if we are having two competing cations, in this aqueous electrolysis we are treating, hydrogen is always present because it is coming from water. Hydrogen is always present since it is coming from water. We say that during aqueous electrolysis, water ionizes. So all aqueous electrolysis we are going to be treated. We are going to have one hydrogen ion and any other cation. So let's say we are treating an electrolysis involving the competition between sodium and hydrogen. Sodium and hydrogen. Since sodium is above, it means that sodium is stronger than what? Hydrogen. And when there is competition between competing ions, strong ones will remain in solution while weak ones will be discharged. Hope you're getting it. So, based on preferential discharge of ions, since hydrogen is weak and sodium is what? Strong, hydrogen will be what? Discharged. It means hydrogen will be removed. And that is the main thing you need to know with respect to this factor that influence preferential discharge of ion. If copper and hydrogen are competing, since hydrogen is above copper, what will happen is that copper will be removed from solution while hydrogen will remain in the solution. Moving to anions. Whenever you are seeing anions, the dominant anion in aqueous electrolysis will always be the hydroxide. Hydroxide is always present because this is electrolysis in the presence of water. So hydroxide is always present. This is hydroxide from water. It will always be competing with a different kind of anion depending on the ionic compound we are using. Take for instance, we are electrolyzing sodium sulfate. This sodium sulfate. SO4 2 minus is the anion. Look at it here. And it is going to be competing with hydroxide, which is here. Now, since SO4 2 minus is above, hydroxide is below, hydroxide will be removed from the solution. We say that hydroxide will be preferentially discharged with respect to what SO4 2 minus. So this is basically the things you need to know as regards to position of ions in the electrochemical series. The strong one remains in the solution while the weak one is discharged, both in terms of cation and what? Anion. And as we move down to the second factor that influences preferential discharge of ion, we want to see concentration of ions in the solution. Now, by this factor, ions that are highly concentrated are prone to be preferentially what? Discharged. This factor is only effective when the two competing ions have a close gap between them. So we'll look more into concentration of ions when we have a question regarding it. But for now, most of the electrolysis we are going to treat is going to be based on this first factor, position of ions in the electrochemical series. So for now, this will be all until I post a new video.